Okay, this is part 3 of my series on how Gundams may be possible. In this part, I'll be addressing the solutions to computing. As I said in part 1, a Gundam is going to need a lot of computing power, as it will need to take in terabytes of information from its surroundings, and it will need to constantly maintain and monitor itself. With so much information needing to be processed, even the most powerful computer today will not be able to perform this feat. So, in order to build a Gundam that's fully capable of being effective on a battlefield, a powerful computer is going to be needed. My first solution to this problem is a quantum computer. A quantum computer is a computer which harnesses the powers of atoms and molecules to perform memory and processing tasks. More specifically, it makes direct use of quantum mechanical phenomena such as superposition and entanglement, which I will get into later. Since 1947, computers have gone a long way in processing power. As Moore's law states, the number of transistors on a microprocessor doubles every 18 months, and by the year 2020 or 2030, the circuits on a microprocessor will be on an atomic level. Therefore, a quantum computer will eventually need to be created, and currently, we are researching in this field intensively. So, like I said, a quantum computer will make direct use of quantum mechanical phenomena, the two being superposition and entanglement. So first, what is superposition? Quantum superposition is a fundamental law of quantum mechanics that defines the allowed state space of a quantum mechanical system. As you all may know, computers today work by manipulating bits that exist in one of two states, 0 or 1. However, quantum computers aren't just limited to states of 0 and 1, but they encode information in qubits or quantum bits that are in states of 0 and 1, hence a state of superposition. Qubits represent atoms, ions, photons, or electrons, and their respective control devices that are working together to act as a computer memory and processor. Because a quantum computer can contain these multiple states simultaneously, it has the potential to be millions of times more powerful than today's most powerful supercomputers. This kind of processing power will make an ideal candidate to be used as a Gundam. On a Gundam. Next, what is entanglement? As I mentioned earlier, a quantum computer takes advantage of the quantum mechanical phenomena, entanglement. Entanglement is a possible feature in the atomic scale in which linkage between two particles, such as two photons or two atoms, are linked in such a way that even though there are two separate particles, they are considered the same entity. So in more clear terms, it basically means that if two particles are in a state of entanglement, then they both duplicate each other no matter how far apart they are. If one electron is light years away from another electron, and if they are in a state of entanglement, then what one electron does, the other one light years away imitates the electron in an instant. This is a very odd feature which seems to contradict science theory that light is the ultimate cosmic speed limit. However, the same laws in the real world are not applicable in the quantum world. And this property of entanglement is of course very useful. So currently, quantum computer research is taking place all over the world. However, one particular company has made it a long way in quantum computer research. Scientists at IBM have made one of the most advanced quantum computers to date. In an article on their website, and I'll put the link on the description, they have designed a test tube with billions of custom designed molecules that have become a 7-qubit quantum computer. With the 7-qubit quantum computer, scientists at IBM have performed the world's most complicated quantum computer calculation to date. And this was with just a 7-qubit quantum computer in a test tube. Once we improve from this point, the potential of quantum computers is almost limitless. Therefore, calculating terabytes of information will be made easy with a quantum computer, and it will solve the computing problem for a Gundam. So that was my first solution to this problem. My next solution may sound a little bizarre, but these do exist today. An alternative to quantum computers are DNA computers. as the name suggests, these computers make use of DNA strands. And it might be surprising, but DNA molecule is actually very similar to computer hard drive in the way it stores permanent data about your genes. So a quick review on DNA. We all know that it's composed of 4 bases, 2 pyrimidines, which are thymine and cytosine, and 2 purines, which are adenine and guanine. And these bases are connected to phosphate sugars through hydrogen bonds, which creates the double helix shape of a DNA strand. And we also know that they hold the genetic blueprint of our genes, which are basically the instructions given for the ribosomes on how to construct the proteins that make up our body. So to give an idea how DNA computers work, researchers at the University of Rochester took the first steps in making a DNA logic gates. For those who don't know what computer logic gates are, they are a vital part of how today's computers carry out functions that you commanded. These gates convert binary code, which in this case are 0 and 1, moving through a computer into a series of signals that the computer uses to perform tasks. So, getting back to what I was saying, the researchers at Rochester have taken the initial steps needed to create a DNA logic gates. Instead of using electrical signals to perform logical functions, the DNA logic gates rely on DNA code. They detect fragments of genetic material as input and splice together these fragments to form a single output. The researchers believe that these logic gates might be combined with DNA microchips to create a breakthrough in DNA computers. DNA computer components, logic gates, and biochips will take years to develop into a practical and workable DNA computer. So if such a computer is ever built, scientists say that it will be more compact, accurate, and efficient than conventional computers. Being much more powerful and efficient than conventional computers, a DNA computer may also solve the problem of computing when building a Gundam. However, the problem I find with a DNA computer will be that it will be composed of extremely fragile components that can be easily damaged, rendering a DNA computer useless. So let's say in battle, if a Gundam is equipped with a DNA computer, then let's say explosions or heavy sound waves can destroy fragile biological components that a DNA computer is made of. However, otherwise, if a durable DNA computer is constructed in the future, then it can definitely serve your purposes for computing involved in the Gundam. So, those were my 2 solutions, which were quantum computers and DNA computers. In the next part, I'll be addressing the problem of the materials used to build a Gundam. So, stay tuned for that, and thanks for watching. Remember to rate and comment, and if I say anything incorrectly, you can mention that in a comment. Alright, thanks for watching.